In this video, I'll be showing us how to build a portfolio project to showcase our SQL skills to potential employers. And the first thing is that to do this, we have to follow a series of workflow. And the workflow that we're going to follow is the first step is like getting the data. And after we get the data, then we load the data. After loading the data, we clean the data and then save the data as a view, and also after that we answer some business questions and save our SQL code and add it to our portfolio project. So for the sake of this portfolio project, you will be working as a data analyst for a fictional company called AutoCare. The dataset we'll be working with is hospital admission dataset in Kaggle. So let's go to Kaggle to look at the dataset. So this is the dataset, which is the hospital admission dataset, and at this right hand side we have the data explorer, which shows us how many datasets are available for us to download. So in this place we have the admission dataset, the HI admission dataset, and also we have the mortality dataset and the population dataset, and also the table headings.csv. So the one we'll be working with is actually the admission dataset. And also we'll be using the table headings to understand what are the different columns that are available in our data. So first, let's go down and see that we have this serial number, we have MRD, which is the medical record number, and we have DOA. So you might be thinking, what does all these columns, what do they mean? Say for example, DOA. So if we click on these table headings, and we come down a bit, you see that all the headings that we have in our data sets, like the SNO, which is the serial number, we have the MRD number, which is the admission number, and we have the DOA, which is date of admission, DOD, date of discharge, age, which is age. And if you go down, you see a lot of what each of the columns means, and there's another one at the bottom which is also important to what we are trying to do, which is DANA, which is also known as discharge against medical advice. To understand more about what we are trying to do, so we go to the about dataset to read about what is the context of this dataset. And looking at this, it tells us that this data was collected from patients admitted over a period of 2 years. So that is from 1st of April 2017 to 31st of March 2019 at Hero DMC at Institute. So for the purpose of our portfolio project, we will be assuming this data is for admission patients for our AutoCare hospital. And specifically, if you read more, you see what this is trying to tell us, that specifically data were related to patients, date of admission, date of discharge, demographics, such as age, sex, locality, and type of admission, which could either be emergency or outpatient. So if you read more on this, you have a better understanding of what the data set we are working with, what it looks like. So another important thing is that if you come down here, there's an option for us to download the data set we want to work with. So let's change this to admission dataset, and once you click on download, this is going to download the CSV dataset that we'll be using in the portfolio project. Right now for our workflow, I've shown us how to get the data. So the next thing that we are going to be moving on is how we are going to load the data into our SQL server. So let's go to SQL server to do that. So this is our SQL server, and right now the first thing we need to do is that we need to create a database for the dataset we are trying to bring into our SQL server. So if I right click on this and click on new database, so let me call this AutoCare DB, so which stands for the AutoCare Hospital database, and let me just click OK. So once you click OK, it's going to add it to the list of the database we have in our SQL server. So for example, if you have a database existing, you see that. So the database we have right now is AutoCare DB, and the next thing we are going to do is then bring in the data set. So to do that, let's right click on this AutoCare DB, and we'll see this window pop up, which you can maybe start a new database, new query. So the one we'll go to is this task option. So once you over on task, it will bring another option for you where you can perform a list of tasks. So what we want to do is that we want to import our data. So the data is CSV file, and the option we have to click is import flat file. CSV file is a flat file. So if it is TSV, it's also flat file. So let's click on import flat file. And once we are doing that, this dialog box comes up, and the next thing you are going to do is just click on next. And it's going to ask us to, browse to the location where the database is, the CSV file is saved. And once I click on browse, so I will go to where it is saved, where my CSV file that I downloaded, the admission dataset that we downloaded, where it is saved. So this is the admission dataset. Once I click on this, so in case you are not seeing the option to select the admission dataset, you can come down here and change this option to CSV or TST. So once you click on admission data, click on open, and it's going to ask you the new table name you want. So what I usually want is that maybe if this is okay for me, then I can leave it this way, but sometimes just remove the HI, so I just leave it as admission data, or let me just leave it the way it is, so as to just, in case I want to make some name changing later. So let's leave it this way. So this is fine. So the next thing, click on this next. So it's going to preview the data you are bringing in, and if there's any issue, you are going to see that at the bottom here. So say for example, it's telling us column name changed due to invalid character duplication, etc. So the next thing for us is to click on next. And right now, this is where you set a lot of attributes or a lot of properties for each of the columns. Say for example, the SNO, the data type is small int, and we want it to become our primary key. Do we want it to allow nulls? So most of all the information you are going to get here, it is not really important for us to make any changes here right now, because this is already a flat file and we are not bringing any additional data into this anytime soon. So we just have an existing flat file that we want to put into a database, and by doing that, we don't need to make any changes to this. We just leave it the way it is. So most of the data types have already been identified by SQL, and I think they are right. So in case you see anyone that are not right, you can make changes to that. But with the look of things, everything feels all right. And the date of admission and the date of discharge have already been identified as a data type. So we leave that the way they are, and we just click on next. So it's going to tell us what it's going to do now, the import information. So this is the SQL Server, my SQL Server name. The database name is AutocareDB, and the table name that is going to generate for us right now is HI admission, and the file, the part where the file is being imported from. So what I need to do is click on finish and then watch as it is inserting. So this is giving us an error. So let's click on this and see what is the error. So it is important you understand this. So it's not going to be straightforward most of the time. So this is an error. So it's looking at this, the column chest infection does not allow DB null value. So that means it does not allow null, but there's a null value existing in a particular column. So what I will do is just click on previous, and then just do allow nulls for everything. So the meaning of allow nulls is that what we are trying to tell SQL is that a particular column can have no value in it. So if you untick this and say untick this allow null, so what you are trying to say is that in DOD, which is date of discharge, there shouldn't be any null value. And once SQL is trying to load this and it finds that there's a null value, then it throws an error. So that is the reason why we are getting that error that we saw initially. So sometimes it's good to have that error so that you can see how to tackle that. So since we are importing a flat file and nothing is going to change anytime soon, so we just click on allow nulls and then we click on next and click on finish. So we should have the right one. So this is telling us there's a warning. So let's open this warning. So it's saying up to 865 cell of data may have been dropped, and The reason why most of them have been dropped is that there might be a problem with the data format. Say, for example, the date inconsistency in some of the date value. So if SQL cannot transform that or cannot match that to a consistent date value, then it's going to drop that. But 865 record is not 865 cells, not record, is not a problem for us. So it's not an entire record that has been dropped. It's just a particular cell value that has been dropped due to a formatting error. So SQL cannot translate that. So we just click OK, and then we click on close. So let's refresh this and open this. So now we have our admission table. So the first thing I usually do when there's a data in the database is just to right click and do select top 1000 rows. So that quickly loads the top 1000 records for me, and I try to inspect and see, do I have a record returned for me or some record to return for me? And then once that is fine, just move around the column and see what we have there. So right now we can see that there's record in our database. We have loaded our admission data into our database. So that is the workflow of loading the data. And the next workflow we'll be going to now is data cleaning. We have to clean our data. So it is very important that when you have a data in a database, you need to clean the data. Majority of the work of a data analyst lies on how clean the data is. So that is why you spend most of your time doing data cleaning. And data cleaning is removing duplicate from our data set, removing inconsistency in data formats, and really removing irrelevant columns sometimes. And also to ensure that our data has a standard structure in terms of the data types. So to perform data cleaning is a very tricky one because you have to understand the data set you are working with, especially doing the tasks of data cleaning. Say, for example, you want to remove duplicate. In our data set, we are already told that, there could be a lot of admission for a particular patient. So if a patient could have multiple admission, then the patient could also have multiple discharge. So that is telling us that if you see multiple admission, that does not translate into a duplicate data. So it's an hospital data set. So definitely people can get admitted in this month and maybe in the next 2 months, another admission. But how do we know what constitutes a duplicate in this data set? Which that is very important because we have to understand that for a complete record, we have to have a date of admission and a date of discharge. So the problem occurs in the data when we have a data with a date of discharge, but there's no date of admission. So it doesn't really make sense because nobody could be discharged without having a date of admission. So you could either be an emergency patient or outpatient. So whatever one you are, there should always be a date of admission and a date of discharge. So what now constitutes duplicate in this data set is to understand that for a complete record, there's a date of admission, a date of discharge, and if you have multiple records having the same date of admission and the same date of discharge, then that is a duplicate. And to do that, we have to write a SQL code to identify or investigate or try to query our data set to see if we can actually find duplicate, because we can't just look at it manually and start trying to identify, oh, this is a duplicate. Though we could do that, but sometimes if you have a record of like 1 million rows, so it is very difficult to just use AI to inspect that. So the best option for you is to find a way to use the software you are working with to actually fish out what are the duplicates in the data set. So for Excel users, you can easily use a function in Excel to get your duplicate. That is very possible, but as a good data analyst, you should understand what constitutes duplicate in your record, because you have to explain to people that you have removed duplicate, and you're having a meeting with your stakeholders and they ask you, okay, how do you know what constitutes a duplicate in this data set? And you said, no, I don't know. I just use an Excel function. Or a button on Excel to remove duplicates, then there's possibility that you might have removed what is not a duplicate. So it is important that you understand that, and with SQL, you can easily write a SQL query to bring out the duplicates. So to do that, let's write the query. So we'll come here. Let me just rewrite this. I'll do select from admission, which is the HDI admission. So I'm just selecting everything first, and by selecting everything, let me load this. And the next thing for me is to check whether there's a duplicate. So to check whether there's a duplicate, what I'm trying to do is that I'll want to identify any record that the date of admission and the date of discharge are the same. So say, for example, I look at record number 1 for date of admission and date of discharge, record number 2, date of admission and date of discharge, and I discover that those two records have the same date of admission, the same date of discharge. That's a duplicate for me. So what I'll do now is that I will use window partitioning to identify the duplicate, since I know that the duplicates are based on 2 major columns. So from there, the next thing is just, let me do this, and I say row number over, so it's going to be over, I'm going to write over and then partition by, I'm partitioning by the medical record number, which will let us see what is the medical record number that has the same date of admission and date of discharge. So MRD, and then followed by the date of admission, and then date of discharge. So I'm going to order this by the medical record number so that I can get that in chronological order. And this column, I'm going to name it duplicate number. So it's going to tell us what is the duplicate number. So I can then order the entire record. So let me do this, order by medical record number. So what this is doing is that I'm going to select every column in this data set, in this table, and then partition the whole data set by the medical record number, the date of admission and date of discharge, and order them by the medical record number. And this column is going to be named duplicate number. So what this will do for us is that it will look at the medical record number, date of admission, date of discharge. So if any medical record number has the same date of admission, date of discharge, then it's going to name that 1. So look for another record number for the same medical record number. If it's the same as the one that has been identified before, then it names it as number 2. So if it is more than 1, then it turns to 2. More than 2, it turns to 3. So if we have like 1 to 3, so what we are trying to say now is that we have 3 records that are duplicate, and we have named that particular column duplicate number, so we can easily track which one is the first one that has been identified, and then how many did he identify. So let's run this. Let's look at this. So we can look at this. We have 1, we have 2 at this point. So let's look at record number 7 and record number 6. So if you look at that, let me click 7 and we go back to this. So this is medical record number 98 and 989, and this is another one again, the same medical record number 989. So the date of admission is 2018 May 12. So 12 of May 2018, and the person was discharged July 12, 2018. So another record again, we have another record again, which is the same date of admission, the same date of discharge. So, and looking at this person again, we can see that, looking across the record, we can see that for the first one, which is this record number 6 that we have identified, we can see that looking across the record, every column value is the same as the one we identified at record number 7, so which is 2018 0512, and look across discharge, the duration of intensive unit stay, and looking again is exactly the same record. So that is a duplicate for us, and if we scroll down again, we will definitely see another one. So looking at this again, this is another one which is on record number 21. On record number 21, so we can see the medical record number for this person is 4973, and they were admitted on 17th October 2018 and discharged on 22nd of October 2018. So the second record identified is the same again, which is the same date of admission, the same date of discharge, and looking across the record, we can see that we have exactly the same value for each of the column. So this is exactly telling us that that is definitely a duplicate record. And looking again, we've identified another one. So let's just inspect again. So this is medical record number 9039. The date of admission is the same as the one we have above it. The date of discharge is the same as the one we have above it. Same for the same medical record number. So that is a duplicate. And what we can do from this right now is that I can turn this into a common table expression so that I can only extract all the records that are not duplicate. So we know that if a record is having dup number greater than 1, that is being identified as duplicate according to the logic of the SQL we have just written. So if a record is greater than, has a dup number greater than 1, then it is a duplicate. So what we are going to do now is that I'm going to create a CTE. So let me just bring this down a bit and say create a CTE. So let's do creating a CTE, which is a temp table. So this will hold all our data, and from this we are going to extract the ones that are clean. So I'm just going to call the temp table the CTE clean data. So called clean data. So to hold all data in the database. Sorry, this will be to extract data, to extract non-duplicates data. So come down here and do read. This is going to be called clean data as, bring this down and do this. So once we have that, this is, we are selecting, this query is that we are selecting all the data to identify duplicate using dup no column generated by window function. So right now that we have this, the next thing we are going to do from this now is that we are going to select the non-duplicate data. So from this, to do that, we just do select non-duplicate data. So for SQL, when you are writing a temporary table, so you don't order it. So I'm just going to comment out the order by. So next thing is then come here and do select everything from our clean data, which is the CTE we created above. So right now, you know, what we are trying to do is to select all the records that are equals to 1. So if you select anything greater than 1 is a duplicate. So for us to select non-duplicate data, we only select record where the dup number is equals to 1. So we do where dup number equals 1. And again, we have a record where the medical record number is null, so it doesn't really serve any purpose for us. So it's just a good thing to, you know, remove that from our data. So and IMRD is not null. So the next thing is that let's run this. So before we run this, if you look at the value of our rows, the number of rows that the previous query returned, it is 15,757. So by running this, let's see what we have. So there's an error. So sorry, I have to run this with a clean data set. So now we have 14,540. So that's more than 1,000 records has been dropped that are duplicates. So that is how to clean our data from duplicate. So right now, since we have cleaned our data from duplicate, and to actually be sure there's no duplicate again, so if we order this by this medical record number to see the medical record number in chronological order. So let's run this again. You can see now that even though we have multiple record numbers right now, if you look at, for example, for this 798, the date of admission is April 5th, 2017, and the person has another admission on October, another admission on April. But if you look at this, there's a discharge on 6th of April, and for this, there's a discharge for it, and for 2019 also there's a discharge for them. So looking at the date of admission, we don't have multiple date of admission for the same person, and looking at the date of discharge, we don't have multiple date of discharge, like the same date of discharge. So this is trying to tell us that our data is now clean, so we don't have any duplicates in this data we have returned. And another important thing is that if you look at this data set again, for what we are trying to do, we don't have anything that we need to work on in terms of formatting. So everything for us is okay, even though a lot of columns here we would not be working with them. But for now, the most important thing is to understand that how to clean the data is very important. How to identify duplicates is very important. And for this healthcare problem, it could be different for a different domain. Say, for example, you are looking at telecommunication, that could be different. You are looking at maybe retail, that could be different. So once we have these clean data sets, the next thing is that we have to save it somewhere so that we know that every time we are querying our data, we are querying a clean data. So how do we do that? To save this somewhere, the best thing for us is to save it as a view. And to save it as a view, we are going to just write another query at the top of this and say we are going to create a view. Say create or author view. So what we are going to call this is admission data. So sometimes it is important that when you want to name your view, you do VW and say admission data. So the VW will let anybody working on this database to know that, or reading your script to know that whatever query we are writing after this is coming from a view and not from an actual table. This notation or this naming convention is trying to tell us that this is a view and not an actual table. So we're going to say as. So it's going to understand everything below it now as a view. So let me just say create a view from the clean data. So one of the advantage of doing this again is that if, for example, something else has changed in the way we are defining duplicate, we can easily come here and make changes to some part of the query and then just run the whole query again, the whole SQL code again, and it's going to override our view. That is why we have done create or alter view. So we can easily just do create view, but sometimes if we make changes to this, it's going to give an error and say there's a duplicate view or there's an existing view. So by writing create or alter, so if this is already existing, so it's just going to alter what is already existing, just like an override. So the SQL code right now is done and we can run this to create our view. But before we do that, we need to comment out order, because when you are creating view, it is okay, or it is important that you don't order the data set that's going to be returned. So to do this, we highlight all these and then execute. So it's going to tell us that the command completed successfully, and when we look into our database, at this point there's a view for us. So if you right click on AutoCareDB and refresh, so open the view, then you're going to see your VW admission data. So this is our clean data set. So the other thing again is that since we are scripting, we are using SQL scripting, so we can also add some useful information to it. So say for example, you are working in a production environment, it is important that you just say you point the SQL script to the database that is meant to use to work to run the script you have written, the SQL code you have written. So to do that, you just use this keyword. You say use the database you are working on is AutoCareDB, and then just do this, say go and do this. So what SQL is going to do right now is that, imagine if I don't put go underneath it, it's going to throw an error. So the reason why it's going to throw an error is that it's trying to run all these as a single batch, and trying to do that, it's a problem because this has to be a standalone. This create or alter view has to be a standalone query, and this use AutoCareDB also has to be a standalone query. And for us to be able to separate that, we use the go keyword and do this. So once we do that, SQL will then run this use AutoCareDB as a single batch and then go into this and run them as a single batch. So once you open the script, it will automatically point it to the right database. So that is for the cleaning of the data. So the next thing, so let me just comment this and say point the script to the right database. So the next thing is that we have our clean data set. The next thing on our workflow is then to answer our business questions. So what are the business questions we need to answer? So we'll be showing us that now. So the business question is that you are a data analyst for AutoCare Hospital, and the stakeholders have come to you and say, we have our admission data set, or there's a database where we keep our admission data, and we would like to see what is the total discharges that we have. And the second question is the average daily discharge rate. The third question is average length of stay distribution of discharges by age group, distribution of discharges by gender, and distribution of discharges by day of the week. So it might be a bit confusing that we have an admission data and the focus is discharge. So in the real world, that is how it works. There's always a focus or domain where you focus your data on. Say, for example, admission and discharge goes together. So we can pay attention to discharge and see, okay, it will work better on discharge, then it will help us have a better planning around the hospital. So things like length of stay would free up bed for other people. If you can see on average, how long are people staying in the hospital? So you try to understand what could be the cause of that. And sometimes the data set could be focused on maybe admission alone to try to, prepare maybe to get more staff. If we can identify a particular day where we have a lot of admission, then we can, bring in a lot of staff on that particular day to help with the amount of admission we are getting. So that is the way it is in the real world. So there's always a focus when we are trying to answer questions. So our focus right now is on discharges. So that is why we have all the questions around discharges, and also we could focus on admission. So for your own practice again, you could try and focus the data on admission and try to see, okay, what is the total admission they get in a day? So an average daily admission rate. Sometimes again, you can twist this around and focus it on another domain when you look at the data set you have. So to answer these questions, we go back to our SQL Server and start writing queries to answer these questions. So let's go to SQL Server. So to do this, we start with our first question. The first question is total discharges. And how do we get that? So first, we need to look at our data set, and this time around we are going to select everything in our data set, and we will be querying from our view. We are not going to be querying from the table again, because we identified that the table has duplicate, and we've been able to extract the non-duplicate data and save it as a view. So everything we'll be doing now, we'll be querying our view that we created earlier. So we just do VW and the view should come up. So right now it is not coming up because this is set to masters, and if I go and just change it to AutoCareDB, so it should come up again. So say VW view admission data. So select everything and run this. So this is our record, and from here now we have to look at total discharges. So to look at total discharges, we have to understand our data set. So discharges is recorded in the outcome data and in the outcome column. So where we have discharge, expiry, and we have another category which is DAMA. So the first one is really straightforward, which is somebody has been discharged. Expiry means somebody died. So these are medical terms which, for the purpose of this portfolio project, you can easily Google more on this and ask them what are the terminologies that you see here. So expiry means somebody died. So DAMA means discharge against medical advice. So for example, somebody came into the hospital and they've been told you are going to stay, let's say you are going to stay 10 days, and they feel like on the 9th day or on the 7th day they are okay, they are fine, and they cannot longer stay in the hospital, or they don't want to stay any longer, so and they leave. So that is discharge against medical advice. They were discharged against the advice the medical people gave. You've been advised that you are going to stay 10 days, but on the 7th day you want out. So that is discharge against medical advice. But that also constitutes as a discharge. But the problem now is that you need to understand what the stakeholder wants. Do they only want all the discharges, whether it is normal discharge or discharge against medical advice, or they just want a normal discharge alone? So that is very important when you are working. So for the purpose of this course, or for the purpose of this video, we are just going to say we only want normal discharges. So if you are discharged against medical advice, it is not really what we are looking for, because it will be difficult for us to actually track or see how your length of stay is affecting the rest. Well, for example, somebody has been put into the hospital and they said they are going to stay 10 days and they left on the 10th day. So that is actually a consistent record that can also be used to, plan the hospital resources, compared to somebody that has been proposed to stay 10 days and they left on the 7th day. So that is what we are going to look at. We are just going to look at normal discharges. So from this right now, what we want to do now is that we want to count all our records. So we are counting everything, and we are going to name these as total discharges. Name these as total discharges, and after that, we are going to then filter our outcome, where our outcome is equals to discharge. And once we run this, let's run this, we are going to see that our total discharges is 12,608. So from the inception of 1st of April 2017 to the last data set, the last date on the data set, which is on 2019. So we have 12,608 discharges. So that is the value, that is the answer to the first question, which is the total discharges. So the second question, which is the average daily discharge rate. Average daily discharge rate. So we need to understand this, and this is actually a KPI. So what we mean by KPI is that key performance indicator. So for key performance indicator, there's always a definition to it. So it is the definition that would actually help us to come up with a formula to measure this. So average daily discharge rate, it is the total discharges divided by the total length of stay. So you can also do some Google search on this to get an explanation of this better. So average daily discharge rate is total discharges divided by the total length of stay. So let me put it here. It is total discharges divided by the total length of stay. And to do that, we can start by understanding that we have total discharges already. We have a query that we have used to get what our total discharges are. So the next thing is to understand how to get our total length of stay, because that is what we are trying to use as the denominator for our formula. So same way, so let's query our table, select everything from the view, and if you run this, we have our data set. And for our data set, we already identified that the discharges is coming from the outcome. What is recording discharges is the outcome column. So length of stay, what is recording length of stay, is the same as the duration column. So sometimes in some places you see it, they record it as length of stay. In some places they record it as duration of stay. In some places they record it as hospital stay. So it has different name, but it means the same thing. So duration date right now is just like from the date of admission to the date of discharge. How long did this person stayed? So for example, this person was admitted on March 7 and they were discharged on March 10. So if you look at the difference right now, this is telling us that from that day to the date of discharge, they are spent 4 days, including the date of admission. The duration is how long somebody has stayed. So that is calculated from the date of admission to date of discharge. So, and from there, we can say it's the same thing as length of stay. So to do that right now, we are going to bring in our total discharges. So since we know that this is going to give us a single value, this is going to give us a single value. So we need to get another single value. Let's calculate our total length of stay. So total length of stay is just select sum. We are summing the duration of stay. And we are calling this as total length of stay. So let's run this. So this is our total length of stay. So the discharge now is going to be divided by this total length of stay. So what we can do right now is that we can bring this down a bit and copy this and do this. So we are going to do this, close this and close this, and then just bring this up a bit. So let me bring this up a bit, use divided by what we have here, and this. So if you do select another select statement on this right now, so let's call this as, before I call this as average daily discharge rate, let me run this. So this is giving us a value of 0, and you might be wondering, why will our average daily discharge rate be 0? So the reason why it is giving us a value of 0 is that the values that we have for the numerator and the denominator, they are not actually a numeric value. So that is why when we do this, the division, we are getting 0. So the best thing for us now is to change this and ensure that we are getting numeric value. And to get numeric value, we don't just use any numeric value. We are going to use a float numeric value, a float data type, to ensure that when we do the division, we can actually get a decimal value. So let me do casting of all these. So casting this. So let's start with this. We are going to cast this first. So we are going to copy, this is our numerator, so we're copying it into this place. And we are going to do cast. So we are casting this as a float. And close this. So divided by, what is our denominator? This is our denominator. So we are going to copy this and paste it here. And we are going to cast this also. I'm going to cast this as float. And so the next thing, let's write our select statement to select the result of this. So let's run all this together and do select. So once we have all this together, you can see that we have 0.136 and a very long decimal. So looking at this, we don't really want that. We just want something straightforward, and we want to also turn it into a percentage by multiplying it by 100. So let's do this. We are going to also cast everything. That is, we are casting our result as a float. So let me do this like this and say cast. We are casting this as a float. So this time around, let's cast it as a decimal so that we can specify how we want it. And in decimal, the first thing is that we have to specify the precision. So this is the precision, and then we'll specify the scale. So we can also multiply this by 100, and then we call this. So let's close these brackets, and then we'll call this our daily discharge, average daily discharge. Discharge rates. Let's run all this. So we have 14% as our average daily discharge rate. So for some of you that might be looking at this query is actually long, and why is this complex? It's not really complex if you look at it. Say for example, what we have done is that since we have our total discharge at the top, we just plot it here and use it to divide our total length of stay. And while doing this, it gave us 0 because these are actually non-numbers. So we have to cast them to number. So that is what we have done right now. We casted them as float, and we're able to turn the counting to a decimal, to a float for total discharges, and for total length of stay, we also changed that to float. And then when we do the division, we converted that to a round number, and that is of 2 decimal points, and we got our average daily discharge rate. So there's a very simple one that we can do by avoiding subquery, because I only wrote this to show us how to use subquery. So we can also do this by avoiding subquery. So let's say avoiding subquery. Avoiding subquery. So we can do select. We want our total discharges, which is when we do our total discharges. So let's do our total discharges. We can do when outcome. What we are going to do now is that every places where we have a discharge, we count it as 1.0 as a float, and if there's no discharges, we count that as 0, so that we can get the actual discharges we have in a decimal value. And for all durations, we also do the same thing. We sum the duration and then divide it, use that to divide the total discharges. So let's do that right now. So we are going to use a case when. So case when outcome is equals to discharge, then 1.0 else. We want to count something else, so it will be else 0.0, and then we end this. So once we have this, so we are going to do that from our view. So once we have this, we are going to use this to divide our total length of stay. So right now we are just going to sum every situation where we have one. So let's sum this and do this divided by the sum of duration of stay. So once we have all this, if we run this, let's run this. So you can see now that we have our value as before, which is 0.136070. So right now we can run the decimal place up and multiply by 100 to get the same value that we got above. So what we are going to do is then put a round, and then we are going to say for everything and do 2 decimal places. We multiply this by 100 and we call this our average daily discharge rate. And let's run this. So we have the same value that we have before. So basically for this question number 2, we've been able to see how to use subqueries, and also we've been able to see how to avoid subqueries. So it depends on how you want to write it. So that is why they say SQL, two people can write this SQL that gives the same answer but different SQL code. So you have to understand how intuitive you can write your code and produce a beautiful result. And also, you have to also think of readability of your code. So if you look at the first query, it's a bit complicated and not that sweet to read. So the second code, which avoids subquery, is very short and also easy to read. So that is how you should think of writing your code. So the third question, that is the one we'll be moving to, which is the average length of stay. So Q3, what is the average length of stay? Also known as ALOS, and this one is also another important KPI, and it is the total length of stay divided by the total discharges. So it is the total length of stay divided by the total discharges. So what we are doing is just basically the reverse of the second calculation, the question number 2, is just reverse of question number 2. So like I said, if you feel these formulas look somehow, you can just try and Google search them and understand better, because sometimes some medical KPIs might sound very funny when you try to reason the formula rationally. So what we're going to do is just use the same formula that we have, the one above that we wrote, which is avoid subquery. So we're just going to reverse that. So let's do that. So I'm just going to say select from VW admission, and I'm going to copy this first, which is the sum divided by this one. And once I do that, the next thing I'm going to say is just say as average length of stay and once we run this, let's see what we have. So you can see 7.349. So it's actually not good to put this in a decimal value, because it doesn't make sense to say somebody have stayed an average of 7.3 days. What does that mean? It doesn't really have a tangible, answer. It doesn't really have a reasonable intuition to that. So what we can do is also round it up and say for this, and if you put 0 and run this, let's see what we have. So you can see now that we have 7.000. So this is more reasonable by saying that we have 7 days average length of stay. That is, on an average, a patient stays 7 days. That is what it means. So now we have answered question number 1, which is total discharges. We've answered question number 2, which is the average daily discharge rate, and then we have answered question number 3 now, which is average length of stay. And we are going to move to the next question, which is the question 4, which is distribution of discharges by age group. So to do that, Q4 distribution of discharges by age group. So if you inspect our data again, So you can look at it and see that in our data, we don't have anything related to age group. We do have something related to age, but there's nothing related to age group. So then we are left into grouping this by age. So sometimes in your organization, things like this might have, their exact way of grouping them. Say, for example, in age grouping, they can say, okay, from a particular age, let's say from 0 to 16, they can say that is pediatrics. From 16 to 65, that is adult. And from that upward, that is senior citizen. And in some places, they can just say anything below 65 is non-senior citizen, and anything above 65 is senior citizen. So different organization, different settings, different domain, they have the way of grouping. But for healthcare, it really makes sense to then group it as pediatrics, adult, and senior citizen, because in hospital they actually have a way of separating children from adults and from adults to senior citizen. So there's pediatric hospital or pediatric clinic or a place where they take care of infant or children. So what we are going to do right now is that we are going to have our grouping to be anything less than 16 should be pediatric, and anything less than 65, from 16 to 65. 16 to 65 will be adults. 16 to 64 will be adults, sorry. That is 16 to 64 will be adults. And anything greater or equals to 65 will be senior citizen. Senior citizen. So what we are going to do from here now, we are going to write a conditional logic, which is case when. So we are going to say case when age is less than 16, then it should be pediatric. So just copy this. And again, when age is less than 65, then that should be adult. And when age is greater than 65 or equals to 65, so else. So we do when age is greater than or equals to 65, then that should be senior citizen. So if any of this condition is not met, so we just do else unknown. Unknown, and we are going to end this and call it age group. So we want to count all these categories right now, so we just do count everything as distribution. Can say age distribution. Age distribution. So this should only be for patient that has been discharged. So the next thing we are going to do is that we are going to say where the outcome is equals to discharge. And the next thing again is that since we have an aggregation function at this place, then we need to have a group by clause. So we are going to group by our age grouping, this one that we have. So we just copy this conditional and paste it here. And after that, the next thing is that we want to order it. So let's run this. Before we order it, let's run this. So let's select all this and run. So you can see now that we have our age group and the age distribution. So for example, we want to see it from the most age distribution to the lowest. So we can then order this and say order by, so the counting, which is the second column, the age distribution, and we want to do it by descending order. So let's do that. So we can see now that we have more adults than senior citizen and than pediatrics. So we have less children being in our age distribution, less children being discharged overall. So that is for question number 4. So going to question number 5, which is the distribution of discharges by gender discharges. So Q5 of discharges by gender. So we are going to check our data, inspect, select everything from the admission data, and let's run this. So we can see that we have gender column, which we can just use directly in our query. So we just do select gender, and then we want to count everything in the category of gender. We are going to name that as gender distribution. So to do that now, we are going to then filter our outcome to discharge, where outcome equals to discharge. And we are going to group by our gender because we have an aggregation column there. Group by gender. And then we want to see it from the top to the lowest. So we are going to order by to descending. So the reason why we are using 2 is that we are just specifying that we want the second column. So we can easily just put count here also. So, and let's run this. So why are we not getting any value? So this is, there's a spelling here. This is meant to be discharge. So now we have our solution, which is we have more male being discharged than female on the data set that we have. There's more male being discharged than female. So the next question is to see the distribution by day of the week. So we're saying Q6 distribution by distribution of discharge by day of the week. So to do this, it's still the same way. What we need is to see the distribution by day of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. What are the distribution for each of those days? So we have our dates already and the date function. So let's inspect our data. So we have our date here. So we don't have the exact day of the week. So we have to bring that out. If we inspect our table, there's no exact column where we have the day of the week. So we have to bring that out from the date value that we have. And we'll be using the date of discharge to do that because we are focusing on discharge as we said earlier. So let's do select. So for us to get the day of the week, there are separate ways of doing it. So I'll show us all the methods, or not all, I'll show us some of the methods. So let's do date part. We use a function called date part. And in date part, it takes in two arguments, which is what we are trying to look for. We are trying to look for day of the week. And the next argument is the date value that we want to perform that on. So it's going to be our discharge date. And we'll call that day of the week. And then we count everything and call this as day distribution. So our outcome, let's copy this, should be discharge, and then we are going to group by the day of the week that we have just created. So we are not going to group by the date alone because that is not used in our query. So what we need to do is that we want to group it by the day of the week that we have created. So group it by this, and then order by this, the distribution. So let's run that. So this is actually giving us the value of the number of the date right now. So if we need the name of the date, there are different ways of doing that. To get the exact name of the day, say for example, we can see that, okay, this is Monday, this is Tuesday, and this is Friday. So to get all those names, so we can rewrite these. So let's do this. So we can rewrite it and say get date name. So let's just copy this down. So we are going to change this from date part to format. And the format is that we are going to format the day of the week, of the date of the discharge as this. So if you do this and you put just 3-letter D, it's going to return it as 3-letter words. Say for example, Monday will be MON, Tuesday will be TUE, so things like that. And then we'll copy this formatted, and then we paste it into our group by, because this is what we need. And once we have that, so we want to remove the null value that we had earlier. So we just say DOD is not null. So we put this into our where clause, and let's run this. So you can see now that we have the result where we have Monday, Tuesday, Wednesday, Thursday. So, but what we have right now is that we can see that the day with the most discharges is Wednesday, followed by Friday, followed by Thursday, and then followed by weekend. So you can look at it that there's a trend that Monday, Tuesday, there's no the discharges are very small, and Sunday the discharges are very small. So it is extremely small in Monday compared to the values we have been looking at. So by looking at this, you can say, okay, maybe there are no more clinician staffs available at the hospital floor to actually assess patients to see if they are medically fit for discharge. Do you understand now? So that is why the discharge rate is that slow. So, and for Wednesday, Friday, Thursday, which we have high number. Let's say, for example, Wednesday, Friday, which we have high number of discharge. It could be, it's getting towards weekend and people feel like they want to spend the weekend with their family. So some people can just feel like, I'm getting better, can I get discharged? And that is some analogy for that. So you need to understand that. So if you want to look at this by saying you want to then order this by the day of the week, which definitely will counter what we are trying to, analyze. So it's okay to just let it be this way and just see that we have ordered them by the day with the most discharges, So that is what we have. So that is how to answer each of these questions. So once we have answered each of these questions, the next thing on our workflow is to see how we can then, save our SQL code and add it as our portfolio. So to save our SQL code, all you need to do is click on this save button and then give it a name that you want. So say, for example, this is our data preparation. So we can save this and call it our data preparation script. And then we can save this and call it our SQL answer. So once we have that, the next thing is to move to GitHub. So we can use GitHub as a place where you save your portfolio project. GitHub can be used to save your portfolio project. And to do that, let me show you how you can actually do that. So let's go to GitHub. So if you don't know GitHub, you have to just go to GitHub and sign up. So once you sign up, you have this page. So let me sign in. So once you sign into GitHub, you need to set up your profile, but that is not what I'm trying to do here. So the next thing is that you might not have anything like this, because I have been using GitHub and I've committed a lot of codes and everything like that. So go to this option of repository at the top here and click on new repository. Once you click on new repository, you'll be asked to give a name for your repository, and say, for example, I can give it the name of our fictional company is AutoCare Hospital. And once you do that, it's going to check if you don't have this existing in your repository. So once you have this, the next thing is that you can give a description for this. This is not compulsory. And the configuration, you leave it as public if this is a portfolio project, so it's good to leave it as public. So the next thing is, say, add readme. So I'll just take this to add a readme file to the portfolio and leave the rest of this thing. So also license, you can use license and put it as a public license. So I'll just use general public license. So click on create repository. And once you have created repository, so the next thing you have to do is to go to the folder where you have saved all your SQL file and everything you work on. So we are going to create a template or a folder structure. We are going to create a folder structure that we are going to upload into our repository. And to do that, so let me go to this folder. So I have a SQL file. So I'm going to create a new folder and call it SQL project. So once I do that, so let me just open this in a new tab. And the reason why I'm opening it in a new tab is that I just want to copy some of these things. So this is my code to clean the data. So in this place, the first thing is that we are going to put a folder called business question. So that will contain every question that we have answered. So if you go to this is the question we have answered. So I've created a text format for the question we have answered. So I'll just copy this and paste it here. So go back to our SQL project, the parent folder again, and then we are going to create another folder called the dataset. So this will contain the dataset we used in the portfolio project. And then, so I'll just copy this into this place. And also, I can create a new text format that will contain the link to dataset. And if I open this, so I'll just copy the link to the dataset. Which is this link. And paste it here. So just close this, save. And the next thing again is that I need to put the solution folder So the solution folder will contain the data prep SQL code, this one, and it will contain the answer to the code, which is also this one. And once we have that, so once you have everything in this order, you know, the business question is here, and the data set and everything is here. The solution is also in this folder. The next thing is that you come to your GitHub page and then start dragging this into this one after the other. So say, for example, you click on add file. So you just have to do is then drag it into this place. Then go to upload file and then select all these three files and then drag them into this place and say project file. So click on commit. So it's going to process everything that you've just added, and if you click on business question, now you can see your questions. If you click on data set, now if you click on this, it should load the CSV so you can view raw. So it's going to take some time. So let me just click back. And if you look at the solution and you click on data prep, so it's just the SQL code that we've written earlier. So that is it. And if you click on this, it's going to show the solution that we have written earlier. So that is how to use GitHub to save all our solution. And we can add this link. You see this GitHub link. When you go to this, you can add this link, this GitHub link. You can add it to your profile and that will serve as your portfolio. The other thing again is that if you go to Alex the Analyst YouTube channel, you can see a video of how you can create your own portfolio website and host it on GitHub. And again, you can also go on this site called Data Science Portfolio. When you go on this site, you sign up and you can create a portfolio website. So you get a link where you can add on your CV or on your LinkedIn profile. So the other thing is that to complete this, we need to work on our README files. So on our README files, there are some things we need to put into it. So I've copied something. So it's just going to be, if you click on edit this file, you'll be able to edit what is here. So I'm just going to call it about project. So let's copy this I have some things that I've written out already, so let me just paste this here. And the other thing again is that we have project objectives. So project objective, so you're just going to click on all these. So the next thing again is that the SQL concept that was used in this project, SQL concept, used. So we copy this and paste it here. And once you click on commit, so you just click on commit, and this will be about our project. And anybody that comes to your portfolio project and they come to this about, they can read what the project is all about and go into this one after the other and see what it means. So that is about the SQL portfolio project. Don't forget to like this video and drop your comment in the comment section, and also share this video to people you feel this will be useful for, and don't forget to subscribe to the channel. See you in another video. Thank you.